Good afternoon, everybody, and welcome to this ASHVIN webinar 3. Sorry for the little delay for kicking out the session, but now our all speakers are on board, and we are super glad to welcome you all to this lunchtime session. So we have 1 hour to discuss the matter of open data and how it can support the maintenance of infrastructure assets. And with this, I would like to warmly welcome also to our 4 speakers from the ASHVIN team who will present you challenges they have faced when dealing with access to open data, but also solutions that we have found in our project. So I'm Mona Maril, I'm the Dissemination and Communication Leader in the ASHVIN project. So ASHVIN is a research and innovation action that is supported by the European Commission. And we have been running for over 3 years, and we have developed a digital solution deploying digital twin technologies to support the European construction sector projects to become more efficient in terms of productivity and safety. But also we tackle questions related to privacy and access to open data, which is the topic of today. So with that, I just would like to remind you that we record the session and we publish it on our YouTube channel, so you can access and share it after it. And also, please keep yourself muted. But it doesn't mean that you cannot speak. We have also time for questions and answers in the end of the session. And right after our first introduction, we have our first interactive moment where we will ask your inputs via Slido. So there will be also an occasion for you to share feedback and comments throughout this hour that we will spend together. So before we start, let me just share you really quickly the agenda, and then I will pass the floor to Jason. So we will first have a short introduction to ASHVIN presented by Jason Pridmore, who is a research and associate professor from Erasmus University of Rotterdam. Then we will have shared experiences from 2 researchers from the project, from Irina Stipanovic from Infraplan Consulting and from Joan Ongodia from Technical University of Berlin, who will share what kind of challenges they have faced with access to open data and what kind of opportunities they also see if we have better access to data and in their projects. And finally, Selma Toktas from Rotterdam University will present what kind of solution for better and secure open data sharing we have come up in the project. So with this, Jason, let me pass the floor to you, and once again, warmly welcome to all of you, and thank you for sharing this time with us.
Thank you, Mona, and I'm glad that everyone is able to join us this afternoon. I do want to give a brief introduction to ASHVIN, and I think basically I will speak to that, but really I will focus on what we're trying to do in this particular aspect of ASHVIN. ASHVIN is a project on digital twinning, and it is about determining how do we better develop our infrastructure, better develop our construction processes through digital twinning and the tools there. One of those topics then becomes how do we think about open infrastructure. And so let me share my screen. I need to find the right button as usual. You should be able to see my screen at this moment in time, and I'm going to focus a little bit, just briefly introducing. You can see my screen.
Yes, Jason, that's good. Thank you.
Yeah, the open infrastructure, correct? Yes. Okay, not the wrong screen. Basically, I wanted to talk a little bit about our experiences and some of the concerns that we have when we start talking about how do we digitize construction sites, and particularly thinking about infrastructure as it progresses into the future, as we end up having increasingly more tools at our disposal. And we're going to talk about some of those different aspects this afternoon, but I want to just tell you a personal story, which was related to This bridge, yesterday I was driving in the Netherlands and I went under this the Nelson Mandela Brug in Zoetermeer. In December of 2022, it was noticed during a routine inspection that cracks had started appearing on one of the columns. Immediately, the government went into action to say, right, we need to close this road. The road was shut down. It is a major thoroughfare to go to Den Haag, to The Hague. I passed by it literally yesterday and was reminded of our meeting today, where there is this certain moment, this privilege of key parts of our infrastructure within the European context that are being evaluated and analyzed to see, is it safe? Is it reasonable? Is it something that we can trust? And I say this because, of course, we know we've had different incidents where we see that some infrastructure is actually not maintained or that there's problems, and then we end up with rather tragic disasters, like the bridge in Genoa. We also see that there were a number of buildings, for instance, in Turkey, where we end up seeing a crumbling process. And so the question for the ASHVIN project, the question for us was, can we begin to think about open and available data that becomes accessed by interested and invested citizens to lead to better infrastructure accountability? Part of the question here, of course, is related to all sorts of aspects of open science, of open access, of open data, all of these questions about transparency and openness. For us, became a question within the ASHVIN project. How do we see this? If we're talking about digital twinning of construction sites and our infrastructure longer term, where we might install sensors, for instance, on roadways, railways, bridges, and buildings, can we start to think about the potential that maybe we make that data open and available? And I was reminded, we had a meeting and discussed this a little bit, and I did not know this word, although I think we all can relate. In Italy, there's this whole discussion about people who are called umarell, usually elderly men, and I really like the one picture in the bottom right here, the corner, where you have someone literally peeking in, of interest in the way in which our infrastructure or buildings are being developed, to see what's happening there. And I think that was also the impetus for thinking about what do we do in terms of open access and beginning to think what could be possible here. And so I use this as a nice example of people wanting to participate, wanting to know, wanting to see and understand. Of course, when we think about infrastructure data, this raises other questions, because there are the potential risks that may happen where we start to note vulnerabilities within our infrastructure that could be exploited or that could simply be politically used in different ways. And so when we start thinking about open data, I'm thinking about opening up a discussion on what's possible for our infrastructure. We raise some concerns here. And so part of the ASHVIN project was to start to think about that, and we're going to get to that in a minute, amongst some other discussions that we will have in terms of some of the research, some of the pilots that we have done. But what we worked on was starting to define an open science approach to infrastructure and maintenance data. It's part of the question that we are going to ask you in a minute, and we talk about this as an ADAPT framework, a way of thinking through this potential, again, within this context of the larger points of ASHVIN, which is how do we effectively create a more sustainable process through digital twinning processes. So I think that's where I will end, just sort of introducing the topic and where we have come from. And I will hand it back over because we have a couple of questions for you.
Thank you, Jason. So now, Natalia, maybe you can open the Slido screen and let's get the first interaction from our participants, just to get an insight. How do you see the open data and the benefits it can help you in your daily work? So Natalia will open the the screen right now. So if you have your smartphones next to you, please use the phone to scan the QR code and participate in the poll. And I will also ask our speakers to join so we can have interaction from not only the participants, but also from the speakers. If you don't have your smartphone, you can open a new screen and go to slido.com and put the code. So now we have 2 minutes just to collect the replies, and then we will display some of your comments here so that we can base this the forthcoming discussion to insights from you people. And I will give you 2 minutes, and then Jason, we can read the results together, okay?
Perfect.
Okay, so let's take 1 more minute to collect replies, and then 2 minutes to see what kind of results we have in the poll. So for those who just onboard us, this is the interactive part before we continue with the presentations from our speakers today. Great, thank you. Okay, thank you for collaborating. So the question was, how have you benefited from open data in your work? So you all come from different fields, research projects, construction sector, or maybe industry related to construction or infrastructure asset management. And here we can see that the open data can provide new ideas, but it also still remains available. It can be used in different new use cases or experiments. It can give input for new design, but also in validation methodologies. And so I think we have all more or less the same approach, that the open data can be used for developing something new and innovative and improve the processes that we have already in place. I don't know if Jason, you resume something else, but this is what I would take off from
No,
this.
I think that was nice to see at least some of those comments, and that a lot of people are using them in research projects. Of course, that makes sense. But the validation and sort of really thinking a bit more intelligibly about the process is also quite interesting.
Yeah. Okay, we have a second question really quickly, 2 minutes again, use the code or the QR for this question. How valuable is open data for maintenance planning? So now we go more deep down to the topic of the day, where we think how the open data can improve actually infrastructure asset management, whether it's airports, roads, bridges, whatsoever. If you come from that sector, if you work with projects on that sector, how do you see that value? Again, please provide your comments, and then we go on with our session, and that will be finished with the Slido for the moment. So here you can just give your rating. Okay, the rating was out of 5 stars, how useful you think the open data is. So we are almost at 5. So I think we can see the value.
There may be a selection bias here. So again, for our, people who are participating, of course, this may be interesting. But I do think that's helpful to remind us that that at least within us, we see this as a critical topic to move forward with.
Exactly. Thank you. Thank you, Natalia. I think you can stop sharing. And now I will pass the floor to Irina Stipanovic, that is the CEO from Infraplan Consulting in Croatia, and also a demo site leader in the ASHVIN project. So the floor is yours, Irina. Thank you.
Thank you very much, Mona. I hope you can see the screen in a full presentation mode.
Yes,
okay.
It's good.
Thanks a lot. I'll talk about basically transport infrastructure management and then why maintenance planning is important. I'll show you what we have done in ASHVIN project, which was focused on the airport infrastructure maintenance planning, and then maybe some other examples of good practice where we used open data. So when we talk about transport infrastructure management, already Mona mentioned, but we talk about railway, highway or motorway road infrastructure, we talk about waterway, and also about the airport. So all of those transport infrastructure networks consist of really complex systems, contain, for instance, bridges, tunnels, which are usually considered as a critical components on the transport network. But also we have longitudinal like roads, pavements or tracks, and as well runways at the airport infrastructure. What are our major challenges nowadays? So first of all, the increased population, especially in the urban environments, which comes also with the increased expectations, with increased number of cars. We are really struggling to make the roads or our railways as well airports open and available. And then on top of that, we have extreme weather events related to the climate change impacts and with the constrained budget. So with all these challenges, of course, we have to optimize our maintenance plans or spending money. Jason also has shown some of the failures, and unfortunately, we are experiencing more and more failures. Why is maintenance important? First of all, of course, to ensure structural safety, but then we have to minimize the lifetime maintenance costs, ensure user safety, and lower the impact on the society as a whole, and lower the impact on the environment. It's exactly what we try to do in the ASHVIN. So we developed a framework of KPIs, and we try to implement into digital twins and then improve the maintenance planning. Now, when we talk about open source data, what type of data we could use for the maintenance planning? First of all, of course, we are using the data from the asset owner, which are mostly related to the BIM models or historical maintenance data. But we could use different sources of sensors, like satellite, like radar or cameras or drone images, or even mobile phones, which could measure acceleration, and we could connect it to the damages on the road, climate data, and different sensors for measuring deformations and load capacity. There are a number of sources of open data which could be implemented into digital twins and could be used for different performance assessment models, but also for the prediction of the future needs and the future scenarios. So the example or the case study we have done in the ASHVIN related to airport infrastructure. So it's a small airport at the coast, city of Zadar. You can see it's really small airport with a pretty aged runway, but the traffic is increasing, we could even say exponentially. So these are per years, and you can see this last year, 2023. So last year they had over 1 million passengers per year. And this is significantly increasing, of course, maintenance need. And we try to support them with developing a digital twin, and then developing a maintenance, optimized maintenance plan. Just one image how AI, when we said we would like to have a smart runway and smart airport, this is how it could look, but basically we would like to have sensors in the runway itself, in the infrastructure around, and of course using different remote sensing methods. So what we have done in ASHVIN, we used a drone to collect high-resolution images. Those high-resolution images were then, let's say, annotated by construction experts or maintenance experts. And those high number of annotated images were used to development of AI model with 4 classes of damages on the runway, which were related to cracks, to repaired cracks, construction joints, and tarmac. And specifically, so those 2 types we try to tackle, so which are related to safety. So for the tire marks are reducing the friction and potentially causing the excursion of the aircraft. And of course, damages and cracks are also reducing the safety in several manners. So you can see here briefly the model, which was developed with the partner CERT, Institute for Technology from Greece. We jointly developed this deep neural network model for the semantic segmentation of damages. And here now I'll show you a very short video. So what is the idea? That we have a drone collection of drone images in several moments over time. Ideally would be minimum, I would say, twice a year. So before summer and after the summer season. From these high resolution images, we would detect the damages and of course, evolution of the damages over time. The damages are then georeferenced and put in a GIS layer. And based on the quantification and classification of the damages, we are then making a classification regarding the condition assessment, and we link it to the traditional standardized methods for assessing the pavement condition index, PCI. And then based on, so that's one moment in time, the condition assessment, and then based on different, of course, historical data and as well on the increased loading and future scenarios, we can predict how these damages will evolve over time. And then, of course, depending on the, let's say, acceptance of the risk, is it the risk avoiding or is it risk accepting strategy? We develop different maintenance scenarios. So the question related, maybe just to mention, of course, you probably know airports are very security and safety specially treated areas, and they are really not sharing data openly. So to challenge, I mean, ourselves in the future. So these are the images we normally, I would say, regularly take from with our phones from the cabin, or when we either take off or land. And even those images are quite valuable because we can see, for instance, you can see here, there is a crack which was repaired in the concrete plate. We can see here there is a rain, and it's actually lower safety condition for the landing. So a number of information could be collected from here, but basically why, if we are allowed to take these images from the airplane, why couldn't be data about the condition of the runway could be shared? And I'll give you now a little bit, just 2 examples from other projects. This was also a Horizon project, and here we developed a network level decision support model for railways, for Irish railways, and we used available LiDAR data, available soil data, and then also the traffic usage, the number of trains, the type of the train, the loading and the track. And we try to, of course, improve as much as possible maintenance plan on the network level. You can see here, it was the assessment of the reliability of the railway embankments. And then based on that, we produced also a 5-year maintenance plan. Another example is, for instance, we in another project, Overflow, we developed a risk maps for flood hazards. And here we use really a lot of open source data. So the first part, you have to do exposure. And exposure means we need the population data, we need the type of land, buildings, the height of the buildings. And of course, it depends very much on the country, I would say, and the policy, how much of this data you will find open. This is a flood hazard.
Irina, I think we missed you. We cannot hear you anymore. Okay, Irina, I think your micro is not working. Are you still with us, Irina?
I see that our image is frozen, unfortunately. So
Okay,
here's
so
the
you're
risk
hurt.
of the, yeah.
Okay, so let's do the following. Let's give Irina some time to recover so that she can conclude right after. And we have another researcher from ASHVIN team who will also present her challenges that she faced with dealing with open data as developing the digital twin solution for ASHVIN. So Joan, would you be so kind and share your screen and share your story related to the faced challenges? So Joan is from Technical University of Berlin, who also managed developing a part of digital twin tools for ASHVIN and also deploying the demo sites. So go ahead, Joan.
Thank you, Mona. Hi, everyone. So basically, in this side, what we really looked at was, in our side, we were looking mostly at one of our partners, their data. So what you see in the red dots are basically the kind of projects they have had over the years across the globe. But then what if we actually could access data from all these different other places, or even in these same regions, if we could have more data? So what really happens is that to us, data is really evidence. So it helps us not really to have to guess so much, but to really go, for example, in this table, I show that what we're calling data is actually evidence as well. So we're calling it evidence-based data. So for example, like the transport infrastructure that Irina was mentioning, say take a road, for instance. Usually for a road, we're looking at the geometry. What is the length? In the case of our partner, we used basically 52999, but actually this is also approximate, again, back to the reason of the data challenges. Because of intellectual property rights and all this, we couldn't use the exact figures here for this presentation, but roughly we used figures which are around what their geometry was. So how we could use this to support maintenance planning is this being a fixed variable, the length, for instance, we could use it to forecast a key performance indicator. Like in ASHVIN, we're basically looking at the cost, the time, and the carbon footprint. And usually you would like to know, for example, what is my time going to be per unit length? That the time that I need for the project to ensure productivity. And then later, what we really did to actually do the optimization for our generative design is that we actually also looked at the actual measures from the projects that have been completed. For example, we looked at, say, the actual project costs between, say, 20,000 euros to about a little over $500,000. So then we looked at the actual project time taken. So why is this more important than if we were just to go in? This really helps us because what has already been recorded for a past project can help us really know more predictively, depending on the situation, what we could maybe plan for in terms of estimations. So this is what we did for our work in the ASHVIN project. And basically, what it would look like in the design space is that you should know, or would start by knowing, what are your key performance indicators. For ASHVIN, we mostly looked at the productivity, the cost, and the resource efficiency. Resource efficiency, specifically the carbon footprint. So basically, all we're trying to really do is that we're trying to say, okay, if this is my cost bound for my project, roughly how much do I need for my project? How much carbon do I need to go or not exceed, for example, in terms of the carbon footprint, that is the dead mass of a material, or even the CO2 emissions from the equipment and all that. So all we did is that all you'd have to do is know your bounds, and then you use that. And then based on the length for the geometry, you then get to know, for example, where the green dots are, is roughly what are my possibilities along the Pareto front. Then if in our case, we also then looked at outputting it in terms of like an XY plot for one to easily interpret or pick up values. So this is really what we did. And this could really help us with maintenance planning. So we know with much more accuracy, better than having just intelligible guesses based on experience. Experience is good, yes, but actually this evidence-based data would really be much more helpful in terms of accuracy. And yeah, so thank you. That's all. Thank you.
Thank you for that testimonial from the project, Joan. Irina, are you recovered?
I'm recovered. I really apologize. So.
No worries. Can you just conclude? I think you had maybe one.
I had one more slide.
Yeah, above. Okay, perfect.
Sorry for this. Really.
No problem.
Okay, so just to conclude, so before that I was saying how we can use for the flood hazard maps the consequences, and we need really a lot of open source data. I gave here some of the examples. Of course, European Commission is really promoting open source data. I can give a really good example also from Slovenia and the Netherlands. For instance, Netherlands really has a policy of open source data, but from Slovenia, for instance, also we use particularly the data about the buildings, and we could get height and occupation. So some countries are really having advanced policy and going in that direction. So just to conclude, we really believe that digitalization and open data will enable the improvement of maintenance models. It will enable us not only to reduce the costs, but also reduce the environmental impacts. Particularly in ASHVIN, we focused on the GC and RISA. We call them the tools which are enabling geolocated condition assessment as a layer, which could be then implemented in different digital tools, and then risk-based maintenance plan. The question I have is, and usually I think different maintenance scenarios are not communicated to the public. So not only to use the open data for the owners to develop optimized maintenance plans, but also to communicate them back to public and for the participatory decision making. And just I would really like to acknowledge the Zadar Airport management team, who were great in collaboration. Thank you very much for the attention. And once more, really apology for this.
Thank you so much, Irina. I think that was really useful insights also to our participants. And also when doing webinars, technical issues happen, right? So we are all used to that. So no problem. Thank you, Irina. Thank you, Joan. So next, we would like to present you the solution we have come up in the ASHVIN project for better and secure open data sharing. And now Selma from Erasmus University of Rotterdam, working together with Jason Pridmore, that we heard at the start of the session, have come up with this solution that could enhance and encourage structures and individuals to work more on this open data sharing for maintenance. So please, Selma, the floor is yours.
Hello, hello everyone. As we've seen in the all presentations so far, and also the results of the Slido, open data has really important, but it undoubtedly has some concerns. So in the ASHVIN project, we generated ADAPT framework as a solution for better and secure open maintenance infrastructure data. In this framework, we structured this framework as an approach to leveraging maintenance data efficiency. So I want to show you our frameworks, and we can delve into each component of this framework and examine how it can be applied into the construction industry. First component is availability. Availability highlights the importance of ensuring maintenance data is accessible and usable by the stakeholders. It is really important to review the availability of data in a way that shouldn't exclude the security of the data. The published data, the published open data should not contain sensitive or confidential information, but it is still necessary to consider what information can be inferred from the disclosed data, while images taken from the construction sites are made publicly available. They should not contain information about other structures around it. For example, Irina shared the Zadar airport. If we take the Zadar airport as an example, sharing images from civilian runway should not reveal movements or any image on the military Zadar airport. It's really important to consider the availabilities of data and its results. The second component is the demonstration. Second component is the demonstration. This component determining the appropriate ways for the demonstration of the benefits and harms of open infrastructure data. And here it's really important, including who is affected while opening the data. Let's consider public infrastructure data. Citizens, researcher, or business can potentially benefit from accessing and contributing to transparency. On the other hand, it's also necessary to take into account what direct or indirect images and damages may occur, because opening infrastructure data can also reveal intellectual property secrets or reinforce data imbalances by providing additional free data to leading companies. So it is really important who is affected from this opening data. The third one is accountability. It is again crucial to define who is accountable for the benefits and harms of opening infrastructure data. The benefits of open data are magnified or increased if there is someone available to answer questions about the data and collect the additional insights and conclusions that data produces. It's also possible the reverse condition. Conversely, if there is negative consequences regarding with opening data, there needs to be a responsible person or organization who will plan the mitigation strategies to limit the possible damages or compensate for the existing damages or harms. The fourth component is our framework is the proportionality. Data should be shared in proportion to the potential risks and gains. The principle of potentiality of data established in the EU Artificial Intelligence Act. We can also use this act and apply to the infrastructure data. The scope and amount of data made available should be evaluated in proportion to these benefits. I would say that the ASHVIN open data pyramid may provide an adequate framework for considering this proportionality efforts. In this pyramid, we distinguish between 4 types of data and associated levels of disclosure: metadata, raw data, reported data, and confidential data. So it is important to consider what kind of data the companies or the people are sharing, and what are their benefits and harms. So it needs to be proportioned. Is it correct or incorrect way? The 4th one is contextualize and create the transparent participation mechanism in the open data efforts. One of the main advantage of open data is organizations can benefit from a wide range of perspective and expertise regarding the content of the data. So it is important to make all these data transparent, who will benefit and share. It could be citizen or researchers or any other stakeholders of the construction industry. So overall, I can say that by embracing the ADAPT framework to construction companies, the stakeholders can receive multitude benefits, not only as Joan presented, that the reduced cost or safety and compliance, but also improving asset performance and reliability, and also better data-driven decision making also possible. It also has many. Advantages also for the citizens. They can engage better in the public decisions. For the researchers, many innovation and good collaborations can be created with the open data. So in conclusion, I can say that the ADAPT framework offers a solution to approach maintenance data management in the construction industry from a data justice perspective. By adopting a systematic open data approach, organizations, researchers, or companies can overcome the challenges of a traditional maintenance practices and pave the way for a more sustainable and efficient future. Thank you.
Brilliant. Thank you, Selma. Now it's time for open discussion. So if you have any questions or comments regarding what was just presented, the floor is open. You can just wave your hand or unmute yourself and share your question. Maybe I have, Selma, one question to you regarding the ADAPT framework that you just presented. If people here are interested in deploying it and adapting it in their own projects, for instance, is it possible? How do you see the future for this solution that you're proposing? Is it something that could be taken forward in next research projects or even at infrastructure management sites if they want to pursue of defining their own process for using open data in a better and secure way?
Yeah, of course, it is not really easy to apply all these projects. While talking about these issues, it's really easy to adapt this kind of framework to the practical issues, but in practical way it is really difficult because there are many stakeholders in the construction industry, especially for example, for one bridge project, there isn't only one owner of the projects. There are many stakeholders, so it is really difficult to get these solutions for the future projects or for the research for the researchers. It is really difficult to make all this data open, because if one stakeholder is willing to share the data, the others are really difficult. Others cannot accept to share this data with the other stakeholders. So I can say that maybe it is difficult, but not impossible. Yeah, maybe I can say this.
Thank you, Selma. Is there any other
I hope
questions?
our framework and also our deliverable a little bit shed light the construction projects. Thank you.
Yes, thank you, Selma. If the participants want to express themselves, the floor is open, so please go ahead and open your mic. We are here to share. I know there is also people from other EU research projects. So if you have any similar activities you want to compare to, now is the time. Otherwise, okay. Otherwise, we can open. We have one final question in Slido. So maybe Natalia, you can open Slido at the same time. And if anyone wants to interact, just please go ahead. Okay, so this is the final question based on Selma's presentation and the framework we just presented you. From your perspective, how helpful do you think the ADAPT framework would be in your projects and in your work? You can score directly on Slido and let's see the reactions.
Yeah, I think Mona, I'm happy to fill in here, especially after listening again to Joan and Irina, and thinking about what Selma and I have been working on struggling with. And I think the key here is we are now seeing, of course, increasing benefits of open data and also the potential use of it and frankly a demand, and this is happening across the board in all sorts of ways. As a researcher myself, you see this happening in terms of scientific articles and access to scientific information. We know that this is also something that open government movements are addressing, trying to create a more open legislative process. So I think there's a natural connection to thinking about infrastructure longer term as it's constructed and as it's maintained over the lifetime of these assets. And I think both Joan and Irina highlighted nicely some of the potentials, but also sort of started to make us think about what are the concerns here and what are the limitations. So I think especially in this slide, it's nice to see that some people are saying that this is a positive way forward, this ADAPT framework. We would like to use it and tweak it and make it more user-friendly and think about, okay, again, there are going to be challenges, and it's the easiest is always to keep our data to ourselves and sort of say we need this for our own purposes. But that the benefits here can outweigh that, but it does take some thinking, and that's what we are trying to do with this framework, is to try and help people think, what do I need to do in order to think through what's possible here. So if there are projects that are interested in talking with us about this or sort of connecting on this topic, you put the link to the open access deliverable there, which is fantastic. We are working on further developing this and publishing on it to try and say, here is a way forward. It will not be the way forward, but it will be a way forward. And of course, to make it a way forward that is really most effective, that does require some feedback. So I think that's the conclusion I have, unless there are people who have questions. Obviously, we had an open moment, but maybe they've come to you in and listening to us and thinking about it.
Yes, thank you. Natalie, can you please stop sharing the screen? So I think we have seen, okay, that's perfect. So that's Jason from ASHVIN team sharing his conclusion. Irina, do you think what was just presented by Selma, what does it bring to you in terms of the airport use case we have had? Do you think that kind of framework could have helped organize the work differently?
Yeah, I believe so. I mean, in the sense that probably it would help communicating also to the owner, structuring the data, and then proving that the data are everything what Selma presented. But I think mostly the communication or the structuring and the sources of the data are treated in a way as they are requiring from, I mean, both sides. So from the user and from the owner of the data, owner's side.
Yes, creating the trust is also in terms of privacy and access, it's crucial when communicating. Okay, thank you so much. So with that, I think if we have no other questions, I will close the webinar for today. So I would kindly like to thank all of our participants. Thank you for joining from this lunchtime session. It was really good to see you all. I will share with this after the session a short survey to collect some of your feedback, but also the recording to YouTube. If you want to share with your colleagues, please be my guest. And also thanks to you of our 4 speakers. It was really, really good to have you all on board to share these research results. With this, thank you all for your time, and let's see in another future session in ASHVIN or other related projects. So thank you so much and have a good afternoon, everybody. Thank you.
Thank you.
Thank you. Bye.